Hello to all viewers of my Facebook channel and YouTube channel. And today we are going to speak about mathematical solution and the math behind this joke where mathematicians come to a bar. First orders 1 cup of beer, the second orders half cup of beer, the third orders 1/4 cup of beer, next 1/8, and so on. And the barman asks, "How many of you are here?" Mathematicians answer, "Oh, almost infinity, very many." "Oh, that's easy then," said the happy barman, and gave them 2 cups of beer for all. So this is the joke about the sum of infinite geometric progression. So let's speak more about the maths behind it. What we can see here is a geometric progression. So the question arises, what is geometric progression? Well, geometric progression is a sequence or series where there are several terms and each term is by n amount of times bigger or smaller than the previous term. For example, there is a first, a second, a third, and a fourth term. So a1 stands for the first term of the sequence, a2 stands for the second term of the sequence, a3 stands for the third, and so on. If I put the following numbers into the sequence, on the first place it will be, let's say, 2. The second one will be 6. The third one will be, let's say, 18. And the fourth one will be 54. So will it be a geometric sequence or not? Let's have a look. 2 needs to multiply by to be multiplied by a certain number to get 6. So what number is it? It is 3. So times 3. 6, if we multiply by 3, will be 18. If we multiply 18 same by 3, it will be 54. So it means that that sequence 2, 6, 18, 54 forms a geometric progression. Why does it form a geometric progression? Because each next number can be obtained from the previous one by multiplying by the same amount of times. So in this case, times 3. And this number, by which you need to multiply previous to get the next member of geometric progression, is called ratio and is denoted by r. So r equals 3 in this case. So since there is a certain law of how to form the next member in the sequence, there are some formulas how to calculate the sum of all of these members. And let's have a look how. So the formula for the sum of geometric sequence with n terms will be u1 or a1 in this case. I'm sorry for the sounds behind my door. There is my 2.5-year-old daughter. And this is inevitable that she can come sometimes and visit me here. So a1 times 1 minus r, where r is ratio, and then power n. So where n is the amount of members of geometric progression which we want to sum up, over 1 minus r. So let's test this formula now on our very simple geometric sequence. So a1 in this case will be 2, then times 1 minus r, so r is 3, so 3. The question is, what will be n? In this case, we want to sum up the first 4 terms of geometric progression. So n will be 4. We can write sum of the 4 members will be 2 times 1 minus r, which r is 3, power 4, since n is 4 in our case, and over 1 minus 3, because r is 3. Let's see now the result of this geometric progression. Let's calculate it. So what will be 3 power 4? Well, 3 power 4 is 81, so it will be 2 times 1 minus 81 and then over 1 minus 3. This is sum of the first 4 terms. So then that becomes minus 2. You can simplify it with 2, and then the result you can divide over minus 1. So the result will be minus 80 over minus 1, which becomes 80. So 80 means that the sum of the first 4 terms will be 80. Let's now use the calculator and see if the sum is really 80. So 2 plus 6 plus 18 plus 54, and indeed this thing is 80. So 2 plus 6 plus 18 plus 54 equals 80. And now the most interesting part begins. What if there will be instead of r equals 3, what if there will be different r, and what if the amount of terms will be infinity? When r is bigger than 0, so when r is bigger than 0, that thing will be always positive. But when r is bigger than 1, so the geometric progression will increase always to infinity, and there will be no solution for the sum of infinity. For example, we can see here that r is 3, which is bigger than 1. So it will be 2, 6, 18, 54, and so on. So that each member will be 3 times bigger than previous, and obviously the infinite, like the member which will stand on the place number infinity, will be infinity on itself. So in case r modulus is bigger than 1, there is no sum to infinity. No sum to infinity. However, when r is bigger than 0 but r is less than 1, there will be sum to infinity, and it will not be infinity. How is it and why? Let's imagine here we have the square. First, I'm taking half of this square, so I'm shading that. Then I'm taking the quarter of the square. I'm shading this. Then I'm taking the eighth of the square, which is that. Then I'm taking the 16th of a square, which is that, and so on. So each next small square, I will be taking half of it, which means that even if I do it forever, I will never shade the whole square. This is the simple graphical explanation of how can it be. Now explanation through the formula. So when r is less than 1, more than 0, each next member becomes smaller than the previous one. So in my task, in my joke, what's happening? The first orders 1 cup of beer. The second orders 1/2. The third orders 1/4. The next one orders 1/8, and so on. So what is r here? By what number do you have to multiply 1 to get 1/2? So obviously by 1/2. By what number do you have to multiply 1/2 to get 1/4? Also 1/2. By what number do you have to multiply 1/4 to get 1/8? Still 1/2. So this is geometric progression, and since we are multiplying by something less than 1, each next number becomes smaller, smaller, and smaller. So when we add them all up, the sum will grow, but grows like slower, slower, and slower, where this is the sum, and this is the actual amount of members, n. So the first member, number 1, it will be 1. Then we add 1/2. Then we add 1/4. Then we add 1/8. Then we add 1/16, and so on. So the sum will grow like that, smaller, smaller, and smaller, since each next member will be twice smaller than previous. So there will be the horizontal asymptote that this sum will never reach. And that will be the upper limit of the sum even at infinity. Let's calculate using the formula. So what is happening now? The formula S infinity will be the same. It will be A1, then 1 minus r, but this time power infinity, over 1 minus r. But since r is less than 1, r to power infinity will be 0. Really, let's have a look. Let's take 1/2 and let's try to put it to the power infinity. It will be 1/2 times 1/2 times 1/2 and so on, infinite amount of times. So it will be then 1/2 power infinity, or 1 over, like 1 power infinity like that, over 2 power infinity. 1 is in any power 1, and 2 power infinity is infinity. So 1 over infinity becomes 0 in the limit. So r power infinity is 0 when r is less than 1. Strictly speaking, modulus of r. So then the formula sum to infinity becomes much easier. It becomes a1 times 1 minus 0 and then over 1 minus r. In our case, r is 1/2 and the a is 1. So let's calculate the sum to infinity. A is 1 because the first ordered 1 cup of beer, times 1 minus 0 is 1, and over 1 minus 1/2. Therefore, it will be 1 over 1/2, and it will be 2. So 2 is our final answer, and this will be sum to infinity. So if there is an infinite number of mathematicians, each of them will keep taking twice less than the previous client. Everyone will take altogether 2 cups of beer, and that's what the happy barman gave them all. Thank you for watching this video. Now, I hope you enjoyed my explanation. If you would like any lessons on mathematics, physics, or economics, please feel free to write me a private message on WhatsApp, and we'll agree upon the time and schedule. Have a nice day to everyone. Don't forget to check on my YouTube channel as well, and see you later with more videos.